Okay, Math 9, so here is a video for exponents called the most complex statements we will learn in this grade. If you really want to challenge, there it is, challenge yourself, this is the video for you. It's grade 10 concepts that we introduce at the very end of grade 9 for those that are interested. So here we go. Wow, look at all this stuff, right? So we're going to combine all of our rules. First thing we're going to do is we're going to do power to a power because we got to deal with the brackets. And we're going to multiply into there, into there, into there, and into there. Now, the a has an exponent of 1, so this is going to become 3 to the power of 4, a to the power of 2, b to the power of 6, c to the power of negative 4. On the bottom, we're also going to have to multiply it into everything. So we're going to have over 3 to the power of 4, a to the power of 12, b to the power of 4, and c to the power of 8. So once we've done that, you would look numerator and denominator. And first look at the numerator. Can you combine anything up there? And you can't. You have 3a, b, c, all different variables. Same on the bottom. But you can divide all of these things. So essentially what we have 3 and then 4 minus 4 because we subtract the exponents. We have a to the 2 minus 12. We have b to the 6 minus 4. And we have c to the negative 4 minus 8. So what does that leave us? That leaves us 3 to the 0, a to the negative 10, b to the 2, c to the negative 12. So the 3 to the 0 is just gone because it's 1. We don't need it. And what we have is we have negative exponents. We have a to the negative 10, b to the 2, and c to the negative 12. And this is where the additional step comes in. If you have a negative exponent, it goes to the denominator to become positive. So you end up with that scenario. There's an additional short video on that. It's bonus, but have a look. So if we really wanted to fully simplify this, we would end up with b squared because nothing's happening there. And then the a goes to the denominator and its exponent becomes positive. And the c goes to the denominator and the exponent becomes positive. So that would be a full simplification of that statement listed above. As you can see, a lot happening. So what about this one? Well, again, this multiplies into there, into there, and into there. This multiplies into there, into there, into there. And then the bottom one multiplies in as well. So we end up with 2 to the negative 2, a now to the negative 4, b to the negative 6, and then times 4 to the 3, a to the 3, b to the negative 3, and on the bottom, a to the negative 12, b to the negative 4. So, wow, lots of negatives. Now let's simplify the top. So you might be looking at 2 to the negative 2 and 4 to the power of 3 and think, well, I don't have a common base, so I'm done. But you do, because look at 4, okay? 4 is just 2 squared. So 4 to the power of 3 is the same as 2 squared to the power of 3. And that helps you out because now you can get a common base, which we'll continue in a minute. Now on the top, you can also combine your a's. You have a to the negative 4 times a to the 3, which gives you a to the negative 1. And you have b to the negative 6 and b to the negative 3, which gives you b to the negative 9. On the bottom, you have a to the negative 12 and b to the negative 4. So now let's continue from the top. So you have 2 to the negative 2, and then the next one becomes 2 to the 6. Remember our power to a power. So that's going to finish us with 2 to the power of 4. And then we have a to the negative 1, and then over a to the negative 12. So we end up with a to the negative 1 minus negative 12, which is going to give us a to the 11. And then we have b to the negative 9 minus negative 4, which is going to give us b to the negative 5. So again, in order to finish this by getting entirely positive exponent expression, the b goes to the denominator. And then our 2 to the 4, you can leave as 2 to the 4, or you can simplify because it's small enough, 16. 2 times 2 times 2 times 2. So this would be a fully simplified form of the question above. Again, this is complete bonus, extra material for those of you that want a challenge. So again, look at all of these negative symbols. So negative 1, multiply in, multiply in, multiply in. Negative 2, multiply in, power to a power, power to a power. So we're doing all of these. Bottom one, 2. So we're going to have 3 to the 1, x to the 2, y to the negative 1, times 5 to the negative 2, x to the negative 4, y to the negative 8, all over 4 to the 2, x to the negative 4, y to the negative 6. So 3 to the 1 is just 3. We'll leave that. We'll put all the numbers first, we'll do the letters after. And then we have times 5 to the negative 2. Now, it doesn't matter what you do to that 5. It's definitely not the same base as 3, and we can't get the same base as 3. So we'll deal with those after. On the bottom, we have 4 squared. Now, on the top, we have x squared and x to the negative 4, which we're going to combine to get x to the negative 2. We have y to the negative 1 and y to the negative 8, which we're going to combine to get y to the negative 9. Remember, we are adding the exponents there because we're multiplying the common base. On the bottom, you got x to the negative 4, y to the negative 6. So now we are subtracting the common base. Now this 5 to the negative 2, since there's no other 5s as a base, it's going to go to the bottom to become a positive exponent. So now we have 3 over 5 squared times 4 squared, and then x to the negative 2 minus negative 4 gives me x to the 2, and then y to the negative 9 minus negative 6 gives me y to the negative 3. So y to the negative 3. So my last step here would be 3x squared, and then get all my exponents positive. And again, you could simplify this. This would become 25 times 16, and then the y comes down to get a positive exponent, right? Y to the negative 3 up here becomes y to the positive 3 down here. And then 25 times 16 is 400. So again, small enough number, but you don't have to simplify any of that. So that would be the completely simplified form of the question above. So I think we got one more. Yeah, real nasty, but here we go. One step at a time. And what I'm going to do in this time is I'm actually going to simplify the inside first, because there's a good amount of stuff we can do in there. Right? We can combine our A's and B's, top and bottom, just to make less work for the water bombing of the exponent, for the power to a powering. So there's not much I can do to the 9, except I might notice that here I have a 3, and here I have a 9. So why don't I try and write all my numbers to the lowest possible base? What I mean by that is 9 is equal to 3 squared. So I'm just going to change that. I'm going to put 3 squared. And then I got a to the power of 1. I'm only working on the inside, okay? So I got a to the power of 1, and on the bottom I got a to the negative 2. So when I subtract those, I'm going to end up with a to the power of positive 3. 1 minus negative 2. And then I have b to the negative 1 minus 2, so I'm going to have b to the negative 3. And so on the bottom, all I have left is that 8. But remember that 8 is also 2 to the power of 3. So I'm going to write it as 2 to the power of 3. And all of that is still to the power of negative 2. But you can see I've condensed my variables on the inside, so it makes things a little bit easier to look at. So for the next side, nothing I can do with the numbers, so I end up with negative 2 minus 2. I get a to the negative 4. I get b to the 3. 2 minus negative 1. And this is over 2, and all of this is to the power of 3. So now I'll multiply those power to powers. And there's just less to do now, right? I got to do those 3, but then yes, I got to get the 1 on the bottom. And I got to do those 3, and yes, I got to do the 1 on the bottom. So now I have 3 to the negative 4, a to the negative 6, b to the positive 6, all over 2 to the negative 6, and then times 3 to the 3, a to the negative 12, b to the 9, all over 2 to the 3. And now the brackets have been busted, so I can combine tops and bottoms if I have a common base. And you can see now all my 3's are in the numerator. So 3 to the negative 4 times 3 to the positive 3 gives me 3 to the negative 1. A to the negative 6, a to the negative 12 gives me a to the negative 18. Remember, I'm adding them. And then b to the 6, b to the 9 gives me b to the 15. On the bottom, I get 2 to the negative 6, 2 to the negative, or 2 to the positive 3, so I get 2 to the negative 3 on the bottom. Now here's an interesting thing. A negative exponent becomes a positive in the denominator. So if you have a negative exponent in the denominator, it becomes a positive exponent in the numerator. So what happens is the 2 goes to the top, becomes positive. The 3 goes to the bottom, becomes positive. And then the a to the negative 18 becomes a to the positive 18 down here. And the b to the 15 just stays. And in this case, 2 to the 3 is a small enough number that we will write 8. Now that is probably one of the most complicated grade 10 level questions. So If you got it, wow, really tough for the current grade 9 level, but definitely where you're going to be heading. If you break this down one step at a time, you'll notice that it's our power to power rules. It's our multiplying a common base rules, dividing our common base rules. The only rule that really jumps out that we haven't really spoken about in detail in this grade because of this bonus is negative exponents. But give it a whirl and have some fun. All right, see you later.